everyone, it's Alyssa and welcome to You Can Learn Math. This is the day of the dreaded factoring with coefficients that are not 1. Dun dun dun. You like a look of horror. Ah! Up until this point, we've been factoring things that were like x squared plus 3x plus 2. Or we might have something where they put a negative in front of that first one. But there's always been an unseen, unspoken number 1 in front of that x. Today that changes. For better or worse, that changes today. Now there's a couple of different ways. Different teachers approach this different ways. So I'm going to show you 2 different ways that are the most common that I've come across, and I'm going to do it a couple times with some different problems. This is one of those things I really think it's helpful to see it a couple of different times. I'm going to do these problems both ways each time. All right, so here's our first one. 3x squared plus 5x plus 2. And as a side note, I'm going to assume that if you're watching this that you have a solid grasp on the style, the x squared plus 3x plus 2 style, and you know what that involves. If you don't, if you feel unsteady about that, please watch the previous videos I have on intro to factoring and also factoring with a negative coefficient. Because I'm going to assume that that's all good, that's all solid, and I don't need to go over those. So please go to those if you need extra help with those. Okay, 3x squared plus 5x plus 2. There is our first number 3. In the previous ones, when we had, I don't know why I erased it since I'm going to rewrite it again. X squared plus 3x plus 2. The question we would ask is what multiplies to 2 and what adds to 3. Okay? That same kind of question is going to happen now, but now we've got this 3 in front of it. So it's not just what multiplies to 2. So for this, we're going to put those 2 together 3 times 2, which gives us 6. So now we're saying what multiplies to 6 and what adds to 5. It's still the 5 in the middle, okay? That doesn't change. We're still saying what adds to 5. Okay. So the beginning is very similar, but this is going to go different very quickly. So just prepare yourself. What multiplies to 6 and adds to 5? Well, if I look at that, I go, 1 times 6 and 2 times 3. Those both multiply to 6. 1 plus 6 is 7. 2 plus 3 is 5. There's my answer, 2 and 3. Okay, so far so similar. However, I'm going to erase this so we have a little more room. Here's where it goes a little different, a lot different. If you're familiar with factoring by grouping, this is where we're going to do some grouping. Previously, once we had that, it's like, 2 and 3, it's going to be x plus 2 times x plus 3. Yay, I'm done. Not anymore. I'm sorry, but it's true. Not anymore. Okay, so what we're going to do, we have our 2 and 3. We're going to split this 5x into those 2 things. Now here's the fun part. Do not worry about what order you put them in. It doesn't matter. It will come out the same either way. And I'm going to prove that to you because you may not believe me, but it's true. Okay, so now I've split that up, 2x and 3x. Now I'm going to group these and I'm going to look for a greatest common factor. In this first one, this first binomial, my greatest common factor is just an x. There's no greatest common factor in the numbers, just in the variables. So I'm going to pull out that x, and that leaves 3x plus 2. All right, my second group. Is there anything I can pull out? Nope. When this happens, this is important, you're going to write 1 times 3x plus 2, okay? That is a trick to remember. Do that. I'm going to say 1 times 3x plus 2. And now, lo and behold, this is what we want to have happen. These match. That's important. So now I can change this into x plus 1 times 3x plus 2. I can take those two together and put them into this new binomial. All right, little side note. Why can I do that? If that's confusing, here's a quick little side note. Let's put some real numbers in here just to see. If I said 5 times 2 plus 4 times 2, what is that? 5 times 2 is 10. 4 times 2 is 8. That makes it 18. Okay? 18. So I have 5 2's. And here I have 4 2's. How many 2's do I have together? 9 2's. 9 is 5 plus 4. Okay? Even if I don't like necessarily using the names for these properties because I think it's easier just to show you. So this is why. This is why we can do this. Because that's all we're doing. It's the same thing. Because this is just a number and there's a matching number. Just like over here. We have the 2 and a 2. As long as those are the same, I can do this. I can pull that 5 and 4 and add them up. And that's what's happening over here. I'm pulling the x and the 1. Okay. And that's it. I've factored it. Now I'm going to show you really quickly. See if I can kind of erase all this. And okay, we're just actually remember x plus 1 times 3x plus 2. Let's remember that. X plus 1 times 3x plus 2. Okay, what would have happened at this point if I did that the other way? So I just had 2x and the 3x there. What if I changed it? What if I'd written it that way? What would have happened? Let's see if I get the same thing, if I had put those in a different order. Okay, let's do greatest common factor out of there. It's x and x. That comes out. But this time I can take out of the numbers as well. I can take a 3 out. That's going to leave x plus 1. On the other side, there are no shared x's, but there are shared numbers, 2 and 2. I can pull a 2 out. It leaves x plus 1. And voila, I can combine these together. 3x plus 2 times x plus 1. Same answer. Woohoo! How about that? Okay. So that's the grouping method. If you are, I'll get ahead of myself. Another method that I've seen teachers do is very similar to the original style of factoring. So I'm just going to show you that one too. It's basically more of a puzzle solving sort of thing, a little more in your head. First, you look at the 3x squared. What multiplies to 3x squared? Well, 3 is prime, so there's really only one option, 3x times x. Okay? Both of my signs are positive. So, and I covered this in Intro to Factoring, that means both of these are positive. And now I have 2. What are my factors of 2? 1 times 2, and that's it. So it's either 1 here and 2 there, or 2 here and 1 there. Well, if I have 1 here and 2 there, I'm going to have 6x plus 1x is 7x. If I put 2 and 1 here, 2x plus 3x is 5x. And there's my factoring. Just looking at it like that, you might go, oh, I would always do it this way. This is easier. Not always. Not always. Especially if you get a more complicated thing, this can be very difficult. So again, it just depends on the problems. It depends on what your teacher is wanting. Please follow what your teacher says, but those are 2 main ways. Here's another example. We're just going to go through a couple of these. If you've already got it with that first example, awesome. That's cool. If you need more examples, let's do those. We want everyone to be able to walk away feeling confident that they know how to do this. Okay, so here we have a bigger number on our end, but we do the same, and we have a negative. We still do the same process. We're going to multiply these two together, and we get negative 28. And our middle number is just 3. So what two numbers add to 3, but multiply to negative 28? Okay, so it's adding to a positive. So I know I'm going to have a positive and a negative number, and the positive number has to be bigger because they're adding together to make a positive. So what adds to 28? Okay, 28 is 1 times 28, 2 times 14, 4 times 7. Okay, I want the bigger number to be positive and the smaller number to be negative. So if I add those together, 28 plus negative 1, 27. Nope. 14 plus negative 2, 12. Nope. 7 plus negative 4, 3. There's my answer. 7 and negative 4. Okay. So again, it does not matter what order I put them in. I will still get the same answer. But I'm just going to write negative 4x and 7x in place of the 3x. Because that's the same. Negative 4x plus 7x is 3x. I can do that. I haven't changed anything. Now I'm going to group things together. On my first one, is there any common factor in the numbers? Yes, 2. Is there any common factor in the variables? Yes, an x. And that leaves behind x minus 2. I'm dividing each of these by 2x. 2x squared divided by 2x is x. Negative 4x divided by 2x is negative 2. That's what happens when I say what's left. I'm dividing that. Since I can multiply and get back to it, so I'm dividing, they're opposites. Other side, right? Is there any common variable? Nope, there's no variable at all. Is there any common factor in the numbers? Yes, 7. I divide both of those by 7. I'm left with 7 times x minus 2. All right, my x minus 2, they match. Woo, that's what I wanted. So these come together and form 2x plus 7 times x minus 2. Okay, now what if we had done it that other method? Okay, where we kind of just look at it. Because we're dealing with like a 2x and a 14, it's still viable to do it this way. It's still, we could do this pretty quickly. All right, 2x squared. What multiplies to 2x squared? 2 is prime, so there's only one option. 2x times x. Okay, there's a negative here and a positive, so I know one is positive, one is negative. Okay, what multiplies to 14? I have negative 1 and 14, 1 and negative 14. 2 and negative 7, negative 2 and 7. Okay, I want a bigger number. The one has to be bigger. What's getting multiplied by the positive has to be bigger because it's going to end up on 3. Okay, so what if I did, let's start with our top one, negative 2 and 7. What if I did negative 2 and positive 7? Oh, I'm already at positive 14. Oh, that's too big. I know that's not right. So I think anything putting a 7 or a 14 here is going to be too big. So already, okay, my 7 or 14 is going to go over here. Okay, so I'm going to try a 7 here and a 2 here. Now the question is the positive and the negative. Okay, 2x times 2 is 4x, and that's 7x. Okay, 7x, 4x, that's 3x different. That's good. And I want it to end up being positive, so the 7 needs to be bigger. So plus here, so I get plus 7x, minus here, minus 4x, and that makes 3x. Okay, so that's still possible. It takes a little more problem solving, kind of like having a puzzle type of brain, but that's how you do it. And that's not for everyone. It's just not. Everybody's mind works differently, so please Use the method that works best for you. And again, I cannot stress this enough, the method your teacher says to you in class, or it says on your test if they're requiring you to use a certain method. Please, please, please. We don't want to lose points for that reason. Okay, now here is our final example. And this is where, okay, it's getting a little tricky. The two methods I showed you, the grouping and the sort of, I call it like the puzzling, we'll call it that. Here we have a prime on the front, so that one's still okay. When you start getting things like 4 or 8 up here, it just gets too difficult. It's a bit hard. All right, so let's look at this. This one's a little more daunting, but we can do this. All right, so 3 times negative 32 is negative 96, and then we have a negative 20. So we want to know what adds to negative 20 and multiplies to negative 96. And you go, oh my goodness, how do I know what multiplies to negative 96? We're going to do a factor tree, okay? Here you go. 96, it's even, so I know 2 goes into it. Divide it by 2, I get 48. Up, even again, so 2 goes into it. 24. Even again, 2 goes into it. 12. Even again, 2 goes into it. 6. And finally, 2 and 3. So 96 is 2 times 2 times 2 times 2 times 2 times 3. All right, how does that help me? Here's how. This is a quick way to get a list of combinations. Okay? First I have, well, of course we always have 1 times 96. We never forget that one. Then I have 2 times 48. Okay? 2 times 48. Next, 4 times 24. Next, 6 times 12. I'm just adding the next one to it. I'm sorry, 6 times 12. 8 times 12. Jeez Louisa. 8 times 12. 2 times 2 times 2 is 8. I'm adding in my head. Shame, shame, shame. All right. 2 times 2 times 2 times 2. Go 16 times 6. Whoops, I should have undone that first before I wrote that. All right. And then finally, 32 times 3. Okay. All right, so there's how we get our combinations. So now this is going to multiply to a negative 96. So in each of these pairs, 1 has to be negative. So we want to see what adds to negative 20. Okay, 96 and 1. Is there any combination of those two? Either negative, positive will get to 20. Nope. 48 and 2. Nope. That'll get me to 46 or negative 46 or, it's like, yeah. Oh, here we go. 24 and 4, because 1 is negative. If I had a negative 24 and a positive 4, that would give me a negative 20. There's our answer. Okay. Now, these aren't the fastest things. They just aren't. 4 and negative 24. Okay, so now I can do my grouping. Okay. So let's see when we do, whoa, accidentally switched to another window. Like, what? Okay, I'm going to change this to plus a negative just to make this, that is a plus a negative. I'm going to scoot this over a little bit just to make this a little easier to see. Okay, plus a negative. All right. So for our first one, common factors. Is there any common factor in the numbers? No. Any common factor in the variables? Yes. I can pull out an x, leaving 3x plus 4. Okay. and plus on this side, negative 24x minus 32. All right, do you see how this over on this side, I have a positive and a positive, and over here I've got a negative and a negative. I'm pulling out, I want what's in this parentheses to match the 3x plus 4. That's my goal, so I always have that in mind. So what can I do to make that happen? I can pull out a negative number, and that'll switch both of those. Okay? So what's a common factor of 24 and 32? 8. But again, I want these to be positive to match this. So I'm going to pull out a negative 8. And that leaves behind 3x plus 4, dividing both of those, negative 24x and negative 32 by negative 8. That's what I get. Okay, so I can combine, and I'm going to rewrite it as x minus 8. Same difference, but it just looks cleaner. X minus 8 times 3x plus 4. Okay, and I think you can see on this, we're starting to get to where it's going to be harder to do it in the more sort of like little puzzle solving way. It's eluding me at the moment, the name for this. I'm sorry. It's early. But this method. Okay, we said what would multiply to 3x squared? 3x and x. Okay, it's going to be to a negative 32. So it could be 1 and 32, 2 and 16, 4 and 8. Yeah. And then we'll say, okay, well, it needs to go to negative 20. And this really is, some people, they can look at this and it just kind of jumps out at them. And they'll go, oh, okay, I know that 8 times 3 is 24 and 4 times 1 is 4. And so 24 and 4, that's 4 apart, and it's a positive and negative. Okay, so if this was a negative 8 and if this was a positive 4, it'd be 4x and negative 24x. If your mind works that way, if you know you're one of those that can see that, again, some people can, some people can't. It is not a reflection on intelligence. It's just like, you know, some people can see color, some people can't. It's just how people think differently. Some people are great at math, some people are great at English, at writing. So if your mind works in that way, that kind of pattern, it's very easy for you to see. That's great. It's not for everyone. So again, that's sort of, if you can see those patterns, and if your teacher's okay with you doing that and not going through the grouping method, then that's the other way to look at that. Okay, so those are some 3 examples. I tried to cover every aspect, the 2 main ways I've seen teachers handle that. So hopefully, you know, your teacher is using one of those in class. If you have any questions or follow-up questions, please leave them in the comments below. All right. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.